Hi friends, sorry. Uh, After a long time I am here with a video. So because of some reason I can't able to make a video. So let's start again today. So in the last video we have discussed about the design of doubly reinforced section, and I think we have completed with an example. So I hope you all understand that example, because no one is doing comments. So I think that I'm teaching very well. Okay, so today starting with another flexural member, means another type of analysis and design of beam is the after singly and doubly. The beam is also been designed as a T beam. Which one? It's a T beam. So what is T beam? So it's a we have discussed a singly reinforced beam. In singly reinforced beam we were doing like this. One beam we draw of B, of D, and here we were providing reinforcement. But after doing a design and after calculating the moment value, the result was coming that in some of the section the required moment was not being satisfied by the provided moments. Means as an example I can say that the required moment is 107. Okay, and the provided moment is coming somehow somehow 90 mm or 90 kilometer into meter. Sorry, means the limiting moment means if I am taking a section of 250 by 400 mm of the beam section, and by the size of the section can only restrain up to the moment of 100 kilometer into meter. But but after calculating by the load, the moment was occurring of 180 kilonewton of meter. Okay, so it means that the section may be failed. Therefore, we provided another section like doubly reinforced beam. So in doubly reinforced beam, we are providing the section upward side. So upward side means a compressive reinforcement. It is used to resist the additional moment. In some cases, if we can't increase the depth of the beam, we can provide another section in the upward side, which is a compressive reinforcement. So, in form of doubly reinforced beam. These two beams we have already understood in the last lectures. Okay, if anyone have missed the last lecture, then I am providing the link here that where you can go and study these two beams. Okay, now let me make you understand about the what is T beam. Okay, now in T beam, let's start with the geometry of the beam. Okay, so here this is one singly beam. In T beam, the difference is that we do not need to provide the reinforcement in the compressive zone. So it is the composite section of slab and beam. It is a mixture of slab and beam. So the flange portion is provided to resist the extra moment in the compression zone. Okay, in doubly reinforced section we were providing the compressive reinforcement, but somehow we think that why to provide compressive reinforcement if we can resist the additional moment by providing the flange section of concrete material itself. Okay, so it's a combination of slab and beam. The shape of flange is like this and the beam is here. So the shape itself named as a T-beam. Okay, so in geometry, this is the width of the flange. This one is the flange portion and this one is the wave portion. Okay, so this width is width of flange. This is the depth of flange. Okay, this is the width of wave. And from here to here is the overall depth. If we are providing reinforcement here, then from here to this center, it is the effective depth. Okay. So it's the mixture of the wave portion and the flange. Wave portion of beam and flange portion of slab. Like this, the geometry of the T-beam is. So how the reinforcement on the T-beam is being placed. So if I draw one plan portion, this is the plan portion of the T-beam. This is one flange. In middle, here it is beam section. So if I draw one beam like this in 3D portion, it will go like this. Okay, and here we are providing a main reinforcement which will go like this. It means the main section, this one is the plan view, front view, which is shown like this. Okay, so here the reinforcement diagram will be like this. Like this. The main reinforcement will be like this. So, if the main reinforcement is parallel to the beam, then we need to provide the distribution steel as a transverse reinforcement in this direction. These all are distribution steel or a transverse reinforcement which we are providing in the slab. Okay, it's not a distribution steel, sorry my mistake, but it is a slab reinforcement. These all are longitudinal one, main reinforcement, and the transverse one means this longitudinal ones means main reinforcement and these are distribution or transverse reinforcement. Like this we are providing the reinforcement in the T-beam section. Okay, now which are the steps to calculating the T-beam? So let's understand that also. Okay, as per the geometry, this one is the T-beam. Now let us understand that which the forces are occurs through the T-beam or from T-beam. Okay, so first of all we draw one stress diagram. So here is a stress diagram. So, as we have studied earlier, in single force, the compressive force, maximum compressive force was 0.36 FCKBXU. Tensile force was 0.87 FYAST. Okay, which was occurring here. C, and which is the lever arm Z. So Z will be D minus 0.42 XU. And T was occurring here. which is 0.87 Fy AST. Okay, these all force are due to B. Okay, so now which the additional force will be occur while providing the flange portion. So the C1 will be 0.36 FCK B WXU. BW means it is due to the web portion of the beam. That's why we are considering the width here BW. Okay, C1 and C2 somewhere here. Okay, as we have studied in the doubly reinforced section that C2 was occurring due to the additional compressive reinforcement. So here C2 will be occur due to the flange portion. So it is nothing but the 0.446, yeah, C2 is the 0.36 FCK BF into DF, or we can say that like this. If we consider a beam portion here, so already this portion is being calculated for compression force, which is C1. Okay, now this portion is only left for the compressive force. So C2 will be 0.446 FCK is the compressive strength. Okay, force is equal to stress into area. So the left portion is BF minus BW. See, C2 will be because of this. So C2 will be, I can say that 0.446 FCK BF means this total length minus BW means we are deducting this portion into DF, this portion. Okay, this will be C2. Okay, which will occur here. So the Z1, this is Z1. So what will be the Z2? So the Z2 will be nothing but D minus DF by 2. It is the CG of the flange portion here. It is the CG of the flange portion. So if in some case, if we need to calculate the T-beam as per the doubly reinforced section, okay, at that time we need to use the theorem of the compression is equal to tensile force as per the neutral axis. Okay, so C1 plus C is equal to T. So C1 plus C2 is equal to T. But mainly there are two forces from T-beam is total force, total compression force. Which is FC, total compression force, which is FC. Okay, due to flange force. So 0.36 FCK BF TF and total tensile force, which is FT. It is 0.87 Fy AST. So this is only compressive force and this is only tensile force. So compressive force for 0.36 FCK BF into DF and tensile force here 0.87 Fy AST. Okay, by this we can decide that in which portion the neutral axis is. Okay, so how we will confirm that where the position of neutral axis is? So there are three conditions. There are three conditions. Okay, first one is if Fc is greater than Ft, it means the force of compression is greater than force of tension. Then the neutral axis will be in flange portion. Means here. If we get Fc is equal to Ft, then neutral axis will be at junction. Means here. And if Fc is less than Ft, then neutral axis will be in wave portion. Means here. So if it is in flange, then we will consider B is equal to BF. If it is in wave or junction, B is equal to BW. Okay, most possibility of these two only. There will be never this condition come that Fc is equal to Ft. Okay, so I hope you all understand the equation which we are going to use to calculate or to analyze the TB. Okay, these all are the equation you need to remind. Okay, if you remind this much equation, then definitely you can analyze the TB. Okay, so now moving to the steps to calculate the TB. Okay,